Okay, hello, welcome. In this video, we're going to look at the basics of classes, and I'll probably talk a little bit about data abstraction, or the idea of creating abstract data types, also known as ADTs. So we're going to cover the basics about classes, so creating classes, accessing the members, what public and private does for classes, and kind of comparing them to structures, so kind of to get into things. I mean, everything that we talked about a structure applies for a class, so they're similar. And then we're going to look at implementing member functions for classes. So when we talked about structures, we only had variables, data items, as members. So we're going to be showing adding functions, member functions, to our abstract data types. And we'll talk a little bit about constructors and destructors for our classes. In this example code, we're going to be continuing on from the list type that I did from the previous video on structures. I'm going to be developing it into a bigger abstract data type. So this list type here. Again, just to say this, I mean, everything that we showed for structures applies for classes. So in fact, structures and classes in C++ are really the same thing. The only difference that I know of, I believe this is the only difference between them, is that by default, everything in a structure is public unless you specify otherwise. And by default, though, it's reversed for a class. So by default, everything in a class is private unless you explicitly make it public. Okay. So what do we mean by private and public? So let me go up and look at the declaration for my abstract list type class here. So I didn't mention it before, but for the assignments for this class, you should have some header documentation before your class, just like I've talked about having header documentation before functions. Okay, but the header documentation for the class, you don't have to document the member functions of a class. You'll use like a function header for those, like we've been using. But it is a good idea to give a description of the class and to maybe document the private member variables of the class. Okay, so looking at our list type. So the purpose of this class is the same as before. We're going to encapsulate and define kind of an abstract list that can hold a variable number of items. And so what we'd like to get to is something that we can add or append items to, and we can remove items from, so we can grow and shrink. And we don't have to know what the size of it is. So a pure, good, complete abstract list type would manage memory for you. You wouldn't have to worry about have I run out of space, have I gone beyond the end of my list, that kind of thing. So here we didn't have these in the structure before, the private and public keywords. Okay, so we've declared we have the same two member variables. These are just variables like our list type for the structure. So we're using exactly the same types of list of variables to implement our abstract list type here. So we're going to keep track of the size of the list, and we're going to use a regular array of integers to hold the items that our list is managing. Okay. But those member variables are private now. So by default, they were public for the structure before, but they're private here. We do have some things that are declared to be public, and these are actually all functions. Okay, these are known as member functions. So the terminology is that variables, we refer to those as member variables. They go by other names, but member variables, and functions we call member functions. Okay. These first three functions are examples of constructors. I'll come back to constructors later. And this one with the tilde in front is the destructor for the class. And then we got some other functions like get size, get item, set item, append item, and so on. Again, if you remember back to my struct video, we had some functions, but they weren't member functions of the structure. They were just a function that took a structure as the first parameter and did something to it, okay? So to me, that's the way that I think of member functions, is what they are just functions who take, the first parameter is just a reference to the class, and then the other parameters. The thing is, though, is that the reference to the class that these member functions work on is implied. Okay, so you don't specify it explicitly, you know, like list type that you have to pass it in all the time, something like that. It's just implied, but it is being passed in. So a reference to one of these list types. And everything that you do inside of these member functions works on that list type. You know, explicitly, it works on like member variables of that class, or the list type in this case. Okay. All right. So those are the member variables. I think I will. Let me come back to the member functions. These getter and setter member functions, these other member functions. Let's look at the constructors first. Okay, so let's start off by looking at the constructors. Okay, so there's three constructors defined for this class. So you can have as many constructors as you want for a class. You can only have one destructor, but you can have many constructors. Of course, each constructor has to be different. So each constructor has to have a different signature. So that means, you know, you can't have two constructors that don't accept any parameters. Like this, right? So that doesn't make sense. Okay, so the signature, the type of parameters that they take have to differ. So the first constructor doesn't take any parameters. The second one takes two parameters, an integer, a size, and a value. The third one also takes two parameters, but the second parameter for this constructor is not an integer; it's an array of integers. So it is actually different than the first one. Okay. Another thing about constructors is they don't return value. They're not even void functions. Okay, so a constructor is a non-returning function. Okay, it's really different from a void function where it doesn't. I don't know how exactly to say it, but void functions, you have to declare that they're void, meaning that they don't return anything. But constructors, they just don't have that at all, right? There's nothing innocent. They don't return anything. Okay, so let's look at the constructor. So the default constructor doesn't do anything except for initialize our list to be empty. So again, remember, there's an implied list being passed here to every one of these member functions. Okay, and then whenever you use a member variable like size here, really what it is as if the class that I passed in, I'm accessing the particular member variable, like size in this case, okay? But both of these are implied. You don't have to spell those out for member functions of a class. So it's implied that it's working on some particular list. And when I set the size variable to 0, I'm setting the size member variable for some particular item to be 0, right? And this is the syntax how you specify something to be a member function of a class. You have to do list type : and then give the class name. So our three class constructors are all going to be list type : list type. So there was the first one, here's the second one. The second one initializes the list to have some number of items, and all those items have some particular values. By default, the value is 0. So if I say I want a list of size 10, whose values are all initialized to 20, it will create the list of size 10, and then it will initialize. It will set all the items to have a value of 20. And then here's our third constructor. That it does something similar, but instead of initializing the values all to one specific value, this initializes all the values to the values that you pass in the array. Okay, so I'll actually talk about that last, so I'm kind of skipping ahead a bit here. So And here's the destructor. Let me again also come back to that, but I wanted to get over to showing some of the other member functions. We'll get back and talk about these, but again, the syntax is everything that's a member function of the list type, you say list type : and then the name of the member function. Okay, the return type goes before, but then you have to indicate that it's a member function of the class, then the name of the member function, and then, like usual, like a regular function, if it has parameters, you have to give the parameter list in here. All right, so we'll come back to those other member functions. Let's look quickly at the constructors. Okay, so if I create a new class of type list type here called empty list. So notice I didn't give it any parameters. I could also have done this the same way by specifying 2 empty parentheses. So this is kind of like you're calling the constructor, and here I'm calling the constructor that doesn't have any parameters. Okay, so I'm calling this is known as the default constructor for a class. Okay, so if I call that, it will do that default constructor, and I think. I didn't try this, but I think I can actually step into that. So let's go ahead and build and try and run and step into and show that it actually does runs the default constructor when I declare this empty list variable of type list type, right? So we'll run. We break here at the top. Let's step. Let me step into to make certain that I. Step into. Yeah. So you see we stepped into, I'm actually into the empty constructor. So that all that happens for this this class is that we set size to be 0 here. So, and which size is being set to 0? Well, let me return the empty list. So empty list has a member variable called size, and we just set empty list size to 0 by doing that. Okay. So now I'm going to show an example of using the get size member function here on the next line. And I'll go ahead and step into it too. Oh, sorry, I messed up. I continued instead of stepping. So let me restart that. Rerun. So we stop here again, but let me step over. And let me step in here. If I step in here, we should step into the get size function before we see the output here. So we'll step in. So we're now in the get size member function. So the get size function in my example code here is an example of a getter function. So all it does, normally getter functions don't take any input parameters, and all they do is they return just one single parameter of the class. So in this case, the get size returns the size parameter, right? So we'll step out of this now. Remember, this was an empty list, so the size should have been 0. So once we step over this, we'll see that it's the value that was returned was 0 for the size here. Okay. So you might be asking, let me stop that there. So you might be asking, so why didn't I just print out, access the size directly like we did for the structure before, something like this. So if I do dot size like that, I should be not get size. If I do dot size, the name of the integer variable, the member variable size, is just size. Okay, so you can already see the squiggly line. So Visual Studio is indicating an error of some kind. The member of list type size here, I can't move it here, but of list type size is declared private. So I wish, again, these messages often aren't as clear as they could or should be. It's inaccessible because we declared it private. So again, it won't even allow me to run this code. If I try and compile it, we'll get a compiler message. So if we build, we'll get an error message. We'll see if the error message is any. So it's the same error message that. This is the second message we get is a little bit clearer. So we can't access the private member, so it's because it's declared private. Excuse me. Declared private in or list type class, okay? And that is true, and that's what private means, okay? So private member variables, or even private, you can have private functions as well. So you can have both private member functions and private member variables. Anything that's private, I can't access outside of the class, but I can access private things inside of the class. So this is what's known as encapsulating data inside of a class in order to protect it from being unintentionally modified incorrectly by outside entities, by things outside of my class here. So, you know, and we already saw examples of, you know, we modified the size private member by initializing it to 0 in the constructor. So it's perfectly fine to modify private things inside of member functions, things that are members of the class. But it is illegal. Anything you declare private cannot be modified outside of the class. You know, so main function is not a member of my list type class. So I just can't do that. If I want to modify it and private things, that's where we use setter methods for. So so yeah, down here I have an example of using the set item setter method. So let's skip down to, actually let's step into that. So I'm gonna have to rebuild and rerun. So we'll build here, and we'll run. F5 to run. So here, set item is another member function. So I created another list. And we used the other constructor. I just skipped over that. So the second constructor initialized the list to have five items. All the items were initialized to a value of 42. So you can look at that constructor yourself. But notice the syntax. So again, it's kind of like calling a function here. We're passing in the two parameters that the second constructor used for the list, 5 and 42. Okay, so let's look at the example of my setter function here. So we'll step into it. So set item, there's some example of doing a little bit of error checking. So the index is supposed to be the index of the item in the list that I want to change, but this list is only of a particular size currently. So in fact, this list size is I gotta step one more, I think. Yeah, it is 5. So the list 1 that I've stepped into has a size of 5, right? So that's a valid, I mean, and the index we're trying to change is 3 here, right? So if I tried to change like -1, I mean, that's not valid. Or if I tried to change an index that's greater than the end of my list, I don't want to allow that either. So we disallow that as well. We get an error message if we did that. But otherwise, we just set the value in our list at index 3 to be this new value. We passed in 5, so we want to change that to have a value of 5. So if you look at the third item, we just changed the item at index 3. We just changed for 5, so we should see that it has a 5. All the items in the list 1 were initialized to 42, but we just changed the item at index 3 to 5. So we see that using the getter to get item, I should have stepped into that maybe. So that was an example of another getter function that just gets an item at a particular index and outputs it. So it was 5. If we get an item like the fourth item, it should be 42 from this constructor. So we'll step over that and show the fourth item is 42. And yeah, just to show that error code again. So the size of my list 1 is it's only got 5 items in it. So it's nonsensical to try to set the 50th item for a list of size 5 to some value, which is what we're trying to do here, right? So if I step into that, we'll see that we're trying to set index 50, but the size of this list is, again, is still only 5 here, if you can see that. So instead of actually setting anything, we'll display this little error message here. right? So this is, I mean, this is to go back to the big picture. I mean, this is why you use setters like this. So you know, my member variables, the size and the items are private, so I can make certain that all my member functions that change those values do it correctly. They don't things like do bounds errors, go past the end of the array, or other things that might be problematic for my data type, right? So in this case, we refuse to go past the end of my list and do something that doesn't make sense. We do an error message instead and do nothing at all, okay? All right. So, I mean, that's the basics of the setters and the getters. Let me show another useful convention in classes. So it's often useful to be able to represent the state of an object or the state of an abstract data type as a string. Okay, so later on we're going to see more powerful ways to do this. Again, if you got this into this in programming 2, you can use operator overloading to do this, to actually overload the output stream operator. But this is kind of working up to that idea. So we can have a two-string member function. So instead of getting individual items, I can call this function. The purpose of it is to represent my list, list 1 in this case, as a string. And then so the two-string function returns a string, and then I output that string to the cout stream. So if we look at it, it might be easier to understand if we just look at what's happening. So let's step in there and look at our two-string. Okay, so I'm using what's known as a string stream here. I mean, this is kind of a big hint. This is something that I asked you to do in programming assignment 2. So instead of outputting to cout, I'm going to output to a string stream, an output string stream. So I just output list size, and I output the size of the list, and then I output all the items in the list. So I use a loop to output the items in the list one by one here. Okay, so the result, I better not go through that loop. The result is, if we continue to here and step out now, and then finally we're going to execute this cout statement, and you'll see the result. So this line here was the string that was created by the toString method. So it represents the current state of my list. The list has 5 items, has a size of 5, and these are the items in it. So the 5 items were initialized to 42, except we changed the item at index 3 to be 5. And remember, that is actually the item at index 3. Remember, items in C array start at index 0. So this was the item at index 0, 1, 2, and then 3. Okay? All right. So there's some other... Okay, so again, talking about this as our list type as an abstract data type here. So let me go down to this append items here. So, I mean, all we've done so far with the list is be able to create a list and initialize it to some particular values, and we could set some particular value by its index. So we could set particular items. But really, like in higher level languages, lists are dynamic. So I can append items to the end of them, or append items to the beginning or in the middle of those, so they can grow. You can also delete items from high level language lists, that kind of thing. So that's really a more powerful idea of a list. It's much more powerful than arrays in C that are a fixed size and they can't really grow and shrink. So that's kind of what we mean by an abstract data type. We don't want to have this really kind of low-level array. We want to have something that's much more powerful. I can just append items to the end of it, or the beginning, or in the middle, or delete items, that kind of thing. So this would be, I don't have all those examples of doing that in this abstract list data type, but I do have like an append and prepend. So we'll look at the append real quickly. This video is beginning to run pretty long. That might be the last one I'll look at, and then we'll go back to the destructor here. So let me continue on, and so we can get to this breakpoint. So we'll continue. I'm right here right now. And then let's step in here. So the purpose of this is to append 16 to my list. List 1 we just displayed. So list 1, again like we did before, just has 5 items in it, these 5 items. So it's of size 5. So we want to append 16, 25, and 36 onto the end of the list, okay? So we'll step in and look at our append item member function. So again, there's a little error checking. In this case, we're checking that we're using fixed sized array, so we're trying to see if we've run out of space, you know. So if this constant is defined to only be of size 100. So if we have more than 100 items in the list, this will prevent us from doing a bounds error again and trying to write into item 101. But otherwise, all this does, so append is pretty easy. To grow my list, all I have to do, since I have enough memory to hold 100 items, if my list is smaller than that, I only have 5 items right now in my list. The size is 5. So I can just add item at index 5. Because if my list is of size 5, the items are at indexes 1 through 4. So I want to add the item at index 5, and then I want to increment size to indicate that I now have 6 items. Okay, so that's how append works in this case. So we now have 6 items. Okay, and we'll append item 25, and we'll append item 36, and we'll now display the list by using that toString again. So, oh, I got a breakpoint here. That's why it keeps going in there. I forgot about that breakpoint. So let's step over, and display our list. So here was after appending those 3 items, 16, 25, and 36. All right. There's a similar function for prepend. I won't show that. I mean, that's more complicated because you want to put the value at the beginning of the list instead of the end. So our array, if I want it at the front, I have to shift all the items. So you can look at that one yourself. But if we call prepend, we want to prepend the squares of 49, of 7, 8, and 9 here. So we'll step over, and we see, I mean, you know, that's not a definitive test that it's working, but we've got these 3 items here prepended, okay? So, and there's an example of some other member functions, you know, so this isn't a complete good abstract data type, but it's beginning to be more useful, basically, okay? So, so I'm just going to step over those. You can look at those yourself. Yeah, and again, this was another example of using the constructor. So this constructor, our third constructor for the list type, takes, instead of taking one value and initializing all the same values, this is an example of passing in an array to a function again. But this constructor copies all these values into my list abstract data type. So if we output this list 2 that we just created, you can see that it copied those 8 items into list 2. Okay, then one final thing here. Let's look at the destructor. So the destructor is called for a class when the class goes out of scope. So at this point, I might have to go back and count them up, but we created several lists. We created the empty list, that's one list. We created list 1, that's a second one. We created another list, that's list 2. And we created something called list 2. So that was, we created 4, if I counted that right, we created 4 classes of list type. So it's actually four lists that are in scope of my main function. Okay, so destructors are called when objects go out of scope. So if I return from main, these were created inside of main. Unless I do something to make these persistent, these objects actually go away. I can't refer to those 4 lists anymore. They were just local to the main function. So that's what's known by going out of scope here. So what you should see is that these four functions the four lists should call their destructor when we exit out of the main function. The destructor doesn't do anything useful right now. It just outputs a message on standard output. Okay, so I'm going to go ahead and step over, and you see if you do that that four destructors were called. The empty list, the first one, and then the other four. The last one we just created had size 8, and so on, right? So, destructors aren't too useful at this point, but later on, let me find that destructor here. Later on, we'll show how you use these when we talk about dynamic memory allocation. So what destructors are used for is to free up memory that you might have allocated dynamically inside of a class to use for an abstract data type. Okay, so I just wanted to make certain that you knew how those worked when we get to that, when we get to talk about dynamic memory allocation. All right, so that's it for this video. So we talked about creating a class. We talked quite a bit about how classes allow you to create abstract data types. Our book goes into much more detail about that, so you definitely need to read the chapter about classes here and about using them as for data abstraction. Looking at constructors and destructors. All right, so that's it for this video. Hopefully that was useful, and I will see you all in the next video.